Multiplying polynomials. In grade 9, you multiplied monomials together. This combined your algebra unit in grade 9 and your exponents unit in grade 9. And when you're multiplying two monomials, a reminder, a monomial is something that is one term. And when you multiplied two monomials together, you multiplied the numbers together. So in this case, we look and say, oh, we have 3 and a negative 8. And if I multiply those together, my numbers multiplied together will give me negative 24. And then we wrote and multiplied our variables together. So in this case, we have an x squared in the first one multiplied by a b squared x and an x to the 4 in the next one. So when we multiplied those out, this is our exponents unit, we'd still have a b squared. But with our x's, what happens when you multiplied an x squared times an x? You would get an x cubed. And we would still have a y to the 4. Now when you multiply an x squared times an x, there's an exponent rule and there's understanding that both tell you that this is x cubed. X squared, the exponent means it's x times x, and then you're multiplying by another x, which would make sense that you would have x cubed, which means 3x's all multiplied together. Your exponent rule said, well, if this was an x squared and this is an x to the 1, what could I do with the exponents? I could add them. When you multiply, you add. Makes so much sense. So our second example says, well, what happens if you have more than two monomials? Well, how do you multiply three numbers together? What do you do?
You do it, well, yeah, exactly. Like you do 2 times 3 and then times that number by 5.
2 times 3 is 6 and times that number by 5. Yes. So you multiply two of them first and then multiply the third one. We can do the same thing here. You can multiply two of them first. So if I choose the first two, what am I going to get? And I would still have minus 2y here. Well, minus 5 times minus 3 is plus 15. X times an x squared will give me x cubed, and y squared would still be there. And now I have these two, and I could do the process again. 15 times minus 2 is negative 30. I still have an x cubed, but now y squared times y will give me y cubed. Do any of you think you could do all three of them in one step? Yes? Because what would you do? You just take all three numbers, negative 5 times negative 3 times negative 2. That would give you 30, negative 30, of course. And then you look at your variables, and you have x and x squared and y, and that would be x cubed, y cubed. So if you did it all at once, that wouldn't be considered bad that you didn't show work. That would be fine. But it's not bad to do it in 2 steps, especially when we get later to 3 binomials multiplied together. This will make more sense to do it 1 step at a time. Here's one for you to try. So I'll do it as if you decided to do 2 of them first, you would have got negative 12a squared b and still have negative 5ab cubed here. If you did it all at once, you would have got 60a cubed b to the 4. Question. In the last 2, this one was a positive answer. This one was a negative answer. Can you come up with a way of just looking at the question at the beginning and quickly saying if you know it's going to be positive or negative? Okay, so an odd number of negative numbers, this one has 3 of them, will always make a negative number. And here we have an even number of negative numbers, which comes out to an even value. Yes. Next, another thing you learned in grade 9, multiplying a monomial times a polynomial. And in grade 9, we gave this a definition. Do you remember learning this set of words together, the distributive property? And when we showed our work with the distributive property, we showed our work by drawing arrows to each thing. And what we were doing, we were distributing, spreading out the 4x to each term inside. And as a result, it's like multiplying monomials 3 times. You multiply the 4x times the x squared, which would give you 4x cubed. You multiply the 4x times the negative 2x, which would give you negative 8x squared, and the 4x times the minus 1 would give you the minus 4x. And you've done this already a fair bit in your factoring, because often you would check to see, did I get my factoring right? Right? This is the factored form where they've taken out the negative 4x, or sorry, they've taken out the common factor of the 4x. And distributing is undoing that to see what it was originally. It doesn't matter where the monomial is, because multiplying in algebra or in numbers doesn't matter the order, it's still the same thing. 5 times 7, right? And this is interesting because there's a certain age where you learn this. 5 times 7 is the same as 7 times 5. You know that, you think that's common sense. But if you find someone in grade 3 or 4 that's just learning to multiply and they still have to add numbers together, when you say, what's 5 times 7, they add 7 plus 7 plus 7 plus 7 5 times, and they say 35 if they're good at adding. And then you go, okay, now what's 7 times 5? 5, 10, 50. And they add 7 5s, and they're like, oh, 35. And then sometime you learn that it doesn't matter the order, and they're the same thing. Right? And you feel kind of mean to that grade 3-er, making them do all the adding twice. But so here, the fact that this negative 8x is on the right side doesn't matter. We can still distribute it. However, in grade 9, you don't very often see it on the right side. So some people go, I don't know how to do this one. But it's the same idea. You could even, if you can't draw backwards arrows, that is just not in your ability set, you could rewrite it with the minus 8x at the front and do your arrows like normal. Okay? If that just, I can't write backwards arrows, that's okay. But if you can write backwards arrows, well, minus 8 times 3x squared minus 8x times 3x squared will be minus or negative 24x cubed minus 16x squared, and the first one will be plus 40x. No problem. Yes? Minus 24x cubed. It doesn't matter what order it's in, because they do mean the same thing. There is a preferred order, and the preferred order is always starting with your term that has the biggest degree. Do you remember that in grade 9? That this one would have a degree of 3 because the exponent is 3. This one has a degree of 2, and this one has a degree of 1. So we like to write it in descending order. All the exponents in a term. So if I look at the 3 terms here, the first term has a degree of 3, the second term has a degree of 2, and the first term has a degree of 1. Just to mix it up a little bit, let's say you had something like just to talk about a bunch of things. Here, the first term would have a degree of 5. The second term would have a degree of 3, because the x has an exponent of 1. And the last one would have a degree of 0. Okay? Because there's no variables whatsoever. When we're talking about the whole thing, what's the degree of the whole thing? We would say that the green one has a degree of 3. We look at each individual one and say, of each individual term, the highest degree is 3. So we would say that the whole polynomial has a degree of 3. In this one, we would say that the whole polynomial has a degree of 5. So that's a little review of degree. And when writing your answer does not matter the order, because just like multiplying, adding doesn't matter the order. 5 plus 7 is the same as 7 plus 5. That's one you can put on a grade 1 or grade 2 student and see what happens. Because they'll probably have to think. They'll do 5 plus 7. They'll take out their hand and go 5 and add 7 more. And then when you do 7 plus 5, they'll have to restart again. And then eventually you learn that adding doesn't matter the order either. We've done this already as well. This is a review. Did you do FOIL in grade 9? I'm not sure. Did we first learn it? Yeah, you did? Okay. Now, we color-coded things so nicely. I'm trying to remember our colors. We did first purple. No. Green was first. Okay. First, and then it was blue. Oh, here we go. I've got it now. And then it was red. No, it doesn't matter the colors. Do we have to get the colors right? No. But we're just trying to be consistent. And when we did this, okay, our green ones, our first ones, our blue ones are outside, our red ones are inside, our purple ones are our last ones, and this is equal to x squared if I color code as I go. And we've already noticed that our outside and inside often combine. And we get x squared plus 2x minus 8. So we FOILed it out, first outside, inside, last. And then we combined our like terms, which ended up with that 2x black in the middle. And we use this to help us figure out. We notice that our first and our last ones always are there in the final answer to help us factor it. But when we get to two larger ones, we can have two methods. And I showed you this already with area as well. Okay. One method is the chart method. Okay. I find out that most students end up using something similar to FOIL with arrows as well. Because what ends up happening is, here I'll split it up. I'll do the arrow method first because that's what most people use going forward. We multiply the first one in the first one by everything in the second one, and we multiply the second one by everything in the first one. We don't have an acronym for this one because it would be first and first inside and then last and then inside and last inside and then last. So it becomes FOIL, something like that, which is not a nice acronym to remember. So we just sort of distribute everything. And when you distribute everything, I'll start with the blue. Can you see in the blue that I would get x cubed plus 2x squared minus 3x? And then I'll switch to the green arrows, and I'd have plus 3x squared plus 6x minus 9. my blue arrows and my green arrows. Do I have any like terms? Yes. X cubed. I have 2x squared plus 3x squared. That would make plus 5x squared. I have a minus 3x and a plus 6, which will give me plus 3x. And I still have minus 9 at the end. I kept the x cubed blue and the minus 9 green because just like foiling where the first and the last show up in the answer, I want to point out that the first ones show up and the last ones show up again, which is a pattern that will help you 12 months from now. So just store it in a part of your brain that you keep important things for later. Now the chart method is the same idea, and we've looked at this before. It's based on areas. So you could write x plus 3 as x and plus 3. And you could write x squared plus 2x and minus 3 and make a chart and fill in all the values of the chart. So as I'm filling in the values of the chart, I'm going to get x cubed, 2x squared, minus 3x. And why did I color code them this way? Just because I like colors. No, not just because I like colors. So that maybe you could see, oh, it is exactly the same as the other idea. Okay? The blue ones match up with the blue ones, the green ones match up with the green ones. And then after you've got your chart, you take everything from your chart, combine the like terms, and you'll get the exact same answer. Right? We only have one x cubed. We have two things that have x squared. We'd add those together and get 5x squared. We have two things with x's, 6x and minus 3x. We'd add those together to get plus 3x. And then we have the minus 9 at the end. The nice thing about a chart method is you don't miss anything. You have to fill in all the parts of your chart. Okay? The not nice thing about your chart method is it takes up more room in your notes than just the arrows. So generally moving forward, students do the arrows because they like to use less space. But both work nicely. Three or more polynomials. This is where we do show our work. It is not easy to do this all at once. There's not good ways to do arrows all at once. And so what we end up doing is choosing two of them, hopefully the easiest two, and multiply those first.
So basically just break it down into two.
Then once you've got two, then you do it again. So here, can you see that I can multiply the first two together? Probably the easiest. How would I multiply the first two? I would distribute. So I'll write that in a set of green brackets. I'll keep the 5x squared minus 2x plus 3, which we haven't touched, in black brackets. What happens when I multiply minus 4x times 3x plus 2? I get minus 12x squared minus 8x. Everybody okay with seeing what happened in green? So I multiplied those two together first, and now I have these two, which you could either use the chart method or the arrows method. The arrows method says this minus 12 would go to each of these. The minus 8, oh, I used green before, so I'll keep it green. Would go to each of those. And if we wrote this out, I'll multiply the blue arrows first. I'm going to get negative 60x to the 4 plus 24x cubed minus 36x squared. Then my green arrows, minus 40x cubed plus 16x squared minus 24x. Once again, we see that now that we're working in algebra, our times table needs to be really, really well known. Because we do lots of times table quickly, and we don't want to be thinking about our times table. We just want to be able to do that because we want to be thinking about the other algebra stuff that's going on. And so the times table should just be something automatic, right? We have lots of things that we need to be automatic. It'd be really hard to live life if, like, oh, I have to think about breathing. When was the last time you thought about breathing? Or it was just automatic, right? So now that we've done our blue arrows and our green arrows, do we have any like terms? Yes, we do. We still have that negative 60x to the 4, but I have a 24x cubed and a minus 40x cubed, which gives me negative 16x cubed. I have a negative 36x squared and a 16x squared, which gives me a negative 20x squared. And I still have the minus 24x at the end. So the only thing that stayed were the first ones and the last ones. All the stuff in the middle, there was some like terms that combined. Example 2, there's an easy way to do this one that's wrong. So don't try to think of the easy way to do it. And it's partly because of a misunderstanding of one of your exponent rules. The number one mistake in this one is just to cube 2x and write 8x cubed, cube 3 and get 27, and say my answer is 8x cubed plus 27. That's wrong because what does a power of 3 or an exponent of 3 mean? This means that this is equal to 2x plus 3 times 2x plus 3 times 2x plus 3. We have 3 binomials all multiplied together, so we need to choose 2 of them to multiply first. And if I multiply these first, I'm going to have to FOIL it out. So that will give me, okay, my blue arrows will give me, my green arrows would give me 4x squared. And by now, are you okay to do the outside and the inside together all at once? Can I just write plus 12x in the middle without doing the green, no, the blue and the red colors? And I still know that this is going to be plus 9 at the end. If you want to do the other step, that is perfectly fine, right? What is the other step that would be right before this? I'll draw it quickly. This is, you would have 4x squared plus 6x plus 6x plus 9, right? If I do all the colors, coding, and FOIL it out one step at a time, that's not wrong. But if you can do the outside and the inside mental math in your head to do 12 right away, perfect. Go for it. And now, I'll move all this down a little bit, just so that I have room for my arrows. And now I'm multiplying 4x squared plus 12x plus 9. Okay? You can choose how you do your arrows. So I'm going to show you that if we usually have the binomial out in front, then our arrows look like this, right? Blue, blue, blue. That one goes to all three. And that one goes to all three. If you did that, perfectly fine. Your answer becomes, do my blue ones, I'm going to get 8x cubed plus 24x squared plus 18x. Those are my blue arrows. And my green arrows plus 12x squared plus 36x plus 27. And we get as an answer in the end, we still have the 8x cubed. We have like terms. X squareds combine, 18x plus 36x plus 54x. We still have the plus 27 at the end. So the black answers are because we were able to combine some like terms. Okay? For those of you that have backwards arrowitis, where you're unable to draw backwards arrows, it's a condition. So I drew backwards arrows, but let's say I have backwards arrowitis and I only draw frontwards arrows. So that means this one goes to those two. This one goes to those two. And this one also has to go to those two. Basically, you take each one in the first one, it has to go to everything in the second one. You will get the exact same answer. Because everything is still multiplied together. You just might have written it in a different order underneath, but that doesn't matter. Can you see that here the arrows get a little bit more confusing because you have more things combined? So it is easier if you can draw the backwards arrows, but not necessary. Here is an application applying the area of a trapezoid formula. Have you ever seen that before? It's actually the same formula. I'll talk about that formula and its interesting stuff after we do the question. So let's do the question first. The formula says the area is equal to base 1 plus base 2. So you have a base at the bottom and you have a base at the top. Depending on which way you flipped it, both of them could be bases. So that's where we have the B1 and the B2. Just means base 1 plus base 2, all divided by 2 times by the height. So if I set up the algebra, my area would equal big set of brackets, base 1, which is 3x plus 2, plus base 2, which is 5x minus 4, all divided by 2, multiplied by the height, in this case, is x plus 2. So now we just have to do the algebra in the same way we would do numbers. Okay? What would you put together first if this was numbers? If it was 5 plus 7 all divided by 2 times 6, what would you do first? You would do the top and add them together, right? So we would get area equals bracket, bracket, all divided by 2. I have some like terms. This becomes 8x minus 2. Still multiplied by x plus 2. If it was numbers, if you had 8 here and 2 here, what would you do? You would divide. Can we divide? Sometimes algebra doesn't let us do what our numbers do first. Can you divide 8x minus 2 by 2? What would you get? 4x minus 1. And now we have a binomial times a binomial, so we can, oh, wrong color. Man. We can FOIL. And we get our final answer to be 4x squared. I'm going to do the blue and red arrows at the same time. Are you okay that I got plus 7x? And then the last one's minus 2. And so that is an expression for the area